Welcome everyone! Today we learn how to use dynamic objects in .NET. So go to Visual Studio and create a new ASP.NET Core Entity application, define the name, select the .NET version and create the project. A dynamic type allows the creation of objects whose types are determined at runtime by passing a static type checking. So go to the program.cs file and from the default endpoint we'll create a new dynamic property. So we'll define the name of the property. We can assign to this dynamic object any primitive value such as a string. We can define Boolean values or integers. It's also possible to assign complex object to this dynamic object. So for instance, if we create a new record called product with a single name property, we can set this property as a new record and it works fine. Consider a real-world scenario in which we want to filter data based on a property name. So create a new endpoint called filter, and from this endpoint we'll use two root parameters. The first one will be the property name, and the second root parameter is the value of the property. Define these two root parameters, remove this code. We will dynamically pass the value type based on the property name and we'll assign this value to a dynamic object. So create a new dynamic property called filter and we'll use a ternary operator to check the property name. So if the field is equal to name, we'll just use the string value, or if the field is price, we'll parse the value as decimal. So we'll call decimal.parse based on the value. Otherwise, it will be a datetime property. So we'll use the datetime.parse method based on the value, and we'll assign this type defined at runtime to a dynamic filter. And finally, we'll apply the filter to any data. While this feature offers a more flexible way to specify types, be cautious of potential runtime errors caused by improper handling. We can convert JSON strings into dynamic objects using libraries such as newtonsoft.json. So create a new endpoint to get the details of a customer. So define the customer root and we'll pass an ID parameter. We'll simulate that we'll get a customer details from external API. So the response from this API will be a JSON string and we'll transform this JSON string into a dynamic object. So let's remove this code and we'll create a new JSON string which will represent the response from the external API. So let me copy some fake data. And now we'll create a new dynamic customer property and we'll use the newtonsoft.json library to transform this JSON string into a dynamic object. So we'll call JObject.parse and we'll pass the string. So we need to install the newtonsoft.json NuGet package. We can switch between dynamic and non-dynamic types. For example, if we want to create a new stream property, which will be the city from the customer, we can access the customer.address.city property from the dynamic object and convert it into a string value. Similarly for the age. Finally, we'll create a new anonymous object to return the city and the age. Let's run the API and test this endpoint. Let's navigate to the customer endpoint, define any ID, and you will see we have an anonymous object with the city and age provided by the dynamic object that we created by transforming a JSON string into the dynamic object. Let's close the API. The dynamic object class provides runtime dynamic behavior. This class must be inherited and cannot be instantiated. So we'll create a new custom dictionary to use a new syntax to access values. So scroll down and create a new class called dynamic dictionary and we'll inherit from dynamic object. Let's create a local dictionary to store the key value paths. So define a new dictionary of type string object and initialize this object. The first method that will override from this dynamic object class is the tryGetMember to get member values. So add the override keyword and invoke the tryGetMember method. So the first parameter includes information about the member, and the second object is the result of the get operation. So we'll try to access a value from the dictionary. So call dictionary.tryGetValue method, and we'll pass the member name, and we'll store the value in the result object. And this method returns a Boolean value indicating if the operation was successful. The second method to override is the trySetMember to set member values. So similarly, we'll override this member. The first parameter includes information about the reference member, and we have the value that we want to store in the dictionary. So from the dictionary, we'll add a new key value pair. So we'll call the add method. We'll pass the member name and the value itself. And we'll always return true from this method because we can always add a new value to the dictionary. So scroll up and add a new endpoint to create a new dictionary object. Define the root of the endpoint, remove the root parameter, remove this sample code, and we'll create a new dynamic dictionary. Create a new instance of the dynamic dictionary class, which inherits from dynamic object. So by using the new syntax, we'll add two properties. Let's rename this dictionary as customer. We'll add two properties. The first one will be the full name. Let's copy this full name from JSON string. And similarly, we'll add dynamically a second property called age. So here we're invoking the trySetMember method to add members to the dictionary, and then from the endpoint response we'll return a new anonymous object with the customer.full name, the customer.age. So we're invoking the tryGetMember method to access these values from the dictionary dynamically using the new syntax. So let's run the API, navigate to the dictionary root. And as you will see, we have a dynamic object using the dynamic object class to add two members dynamically, the full name and the age. Close the API. If we try to access a member that is not found in the dictionary, it will throw a runtime binder exception. So let's try to print by a console customer.address, which is an unknown property from the dictionary. It will throw a runtime binder exception. Run the API and navigate to the dictionary endpoint. And as you will see, it throws a runtime binder exception because the dictionary doesn't contain a definition for the address. The member is not found. Stop the API. The ExpandoObject class allows us to add or remove members dynamically. So create a new endpoint called Expando, and instead of using the custom dictionary, we'll create a new ExpandoObject, and we'll add dynamically these two properties, the full name and the age. And we can also add nested properties dynamically. For instance, if we want to create a new address property, we'll create a new ExpandoObject, and for this we'll define the city. Scroll up and we'll copy this sample city. Let's remove this line and add the customer.address.city in the endpoint response. Let's test this endpoint. Navigate to the Expando root, and we have a dynamic object using the ExpandoObject class to add properties dynamically, the full name, the age, and the city property. So close the API. Finally, we can remove dynamic properties using the remove method from the iDictionary interface. So we'll print via console the customer.address.city and will dynamically remove the address property from this customer object. So for that, we need to access the ID generate interface of type string object from the customer dynamic type, and we'll call the remove method and we'll pass the member name as an argument, which in this case will be the address. And the endpoint response will throw a runtime bundle exception because the address property is removed from the dynamic object. Run the API, navigate to the endpoint, and we have a runtime bundle exception because this ExpandoObject contains the definition for address, but you will see in the console that we printed the city from the address property, and we dynamically remove this property, and the endpoint response will throw an exception to stop the API. In this demo, we've learned how to use dynamic objects in .NET.